Hello students, today's agenda is to check homework. We'll be finding angle measures in parallel lines and you will be able to do 7.6. Today students will be able to find angle measures by using parallel line theorems and postulate. And before we start, I want to include some more new theorems which are related to the previous ones. If you remember, we had the corresponding angles postulate. Again, postulate means that you take as true without proof, just because you can just basically see it. The converse, and this refers that if you have a pair of parallel lines, then the angles are congruent. In here is the other way around. If two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So before, you knew that the lines were parallel, so it gave you corresponding angles that are congruent. Now you have corresponding angles that are congruent, therefore the lines are parallel. So they're very similar. So in here it says, these two markings show me that they are congruent. That means that they have the same measurement. By having that, then we can say, oh, if they are congruent, then the lines are parallel. Okay? If the angles are congruent, then line L is parallel to line K. For the converse of alternate interior angles, if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. Again, they are giving us the angles being congruent. If it has one marking in here and one marking in here, that means that these two angles are congruent. If you remember, this is letter Z. Letter Z, and the way to remember is from A to Z, right? So when you see letter Z in here formed by the two angles that they are telling us that they're congruent, then we can say that it's related to alternate interior angles. And so it says, if angle 1 is congruent to angle 2, this angle and this angle, then line L is parallel to line K, okay? For the other one, it says converse of same side interior angle theorem. If two lines and a transversal form same side interior angles that are supplementary, then the two lines are parallel. What is supplementary? It means that the two angles on the same side the sum will be equal to 180. And here it says, if angle 4 and angle 2 are supplementary, then line L is parallel to line K. Corresponding, and here you have two R's, and then in here you have like two L's. If you notice, they look like two L's in here. An L and an L are R. And that's just to remember, and those are equal in measurement. They are congruent, okay? Alternate interior angles. Alternate because they're on the other side of the transversal. One is on one side and the other one is on the other side. And interior because they're inside of the parallel lines, okay? So alternate, one that way, one that way. Interior, inside of the parallel lines. And these are also congruent. They are the same measurement. This symbol here means congruent. Okay? In this one, same side interior angles, they are on the same side and they will never, well, only if there are 90-degree angles, but otherwise they will not be the same size or the same measurement like the other two. These are the same measurements, same same measurement, but for these ones, they add to 180. So if this is 120, this will be 60. If this is 100, then this is going to be 80 degrees, okay? Same side interior angles of all three parallel lines, all three pairs of angles formed by parallel lines. This is the only one that is 180 degrees. The other ones, they are the same measurement. Here you have a cheat sheet. These three pairs of angles are congruent. That means that they are equal to each other. And I'll explain them in detail. All these three, and we haven't seen this one is for next lesson, but these, they add to 180 degrees. They are supplementary angles. So let me explain it. Oh, and the other thing that you need to know is that these are formed by parallel lines and not transversal. These are the ones that we learned in previous lessons, okay? We have the supplementary adjacent angles and we have vertical angles. And these we'll learn in the next lesson. So corresponding angles, if you notice, if we were to cut this transversal and overlap it, this means that this is on the same position. It corresponds to this one. And I put the purple color in there. You can barely see it, but this is purple, this is purple. And if you notice, you can see that they are the same measurement. Then this is orange and this is orange, and also they look the same measurement. This and these are pink, they are the same measurement, and then the green and the green also the same measurement. What does that mean? It means that if you had, for example, x plus, I don't know, 60, and then in here maybe 2x minus 10, then you can figure out the measurement of x by putting x plus 60. You're not going to add the two angles, you're going to put equals 2x minus 10. And the reason is because they are congruent, so you put an equal sign in the middle. On this side, then you would have to add the two angles, okay? But we'll go into more detail with that. Let's go ahead and solve it. You add 10 to both sides. You get 2x equals x plus 70. Subtract x from both sides. 70 is equals to x. That means that you can replace in here 70 plus, and it's basically not accurately because I just made it up and that looks less than that. But basically, to figure out what this measurement is, you just replace it with 70. 70 plus 60 is equal to 130. This will be the measurement more of the bigger side, so maybe I should switch it over there. And then in here, 2 times 70 minus 10, 2 times 70 is 140, minus 10 is equals to 130. If you notice, they are equal, they are the same measurement, okay? Alternate interior angles, remember that those are the ones that form the Z, de la A la Z. See? To remember the name, you can just say from A to Z. So whenever they form the Z, is alternate interior angles. Again, you will have something like this. This is one measurement, this is the other. You put the equal sign in the middle. Also for vertical angles. Vertical angles, if you have a measurement in here and another one in here, you just put an equal. You put the amount in here equals the other expression in here. And then you start solving. Okay, so that's for congruent angles. What do you do for supplementary angles? Okay, now for supplementary angles, again, these come from parallel lines. In here, you're not going to put an equal in between the two expressions. What you're going to do is you're going to put plus in there. So let's say that this is maybe x plus plus 20, and maybe this is x maybe plus 2. So you're gonna have to, and this usually has a degree in here, you're gonna have to do for these type of pairs of angles, you have to put them together, x plus 20, that's one of them, plus x plus 2, and that's going to be equals to 180. Remember, for all supplementary angles, it's always equals to 180. So x plus x is 2x, 20 plus 2 is 22, equals 180, minus 22. Now we're just solving. You get 2x is equals to 158. We divide both sides by 2. And I'm running out of space here, sorry. Half of 158 is 79. So x is 79 degrees. Okay, so again, if it's one of these type of angles, you put an equal sign in the middle. If it's one of these type of angles, you put a plus sign in the middle, put equal 180, and then start solving for the value of x. Now what this means is that I can replace the x with 79, so 79, and that's the value of x, plus the 20 here, that's going to be equals to 99 degrees. Now in here, if this x is 79 plus 2, that gives me 81. And notice how when I add these two together, that's going to be 99 plus 1 is 100 plus the 80 is 180, which is what makes them supplementary. Okay? Same here, whenever you have a straight line and it's split into two different angles, if you have an expression in here and another one in here, you put a plus and then equals 180. Okay, this is also supplementary angle. When they are adjacent, and I say they form the half orange. And for the triangle angle sum theorem, we're also going to learn that all angles in a triangle always add up to 180 degrees, but we'll see that in the next lesson. Okay, now let's go to do some examples. So in here we have these parallel lines, same side interior angle. So if this is 48 degrees, what's the measurement of angle 1? Well, all you have to do is just get 180. Remember that supplementary or angles on the same side of the transversal are going to be supplementary. So 180 minus 48, you get 10 minus 8 is 2, 3, 1. So angle 1 is 132 degrees. Now in here, if you notice, and you can do different combinations right here. Now we have this one, which is 132. This is Z backwards, right? Well, not backwards, but if you see it like this. Since this is 132 degrees, this is also 132 degrees. And that's for angle 3. I was going to put it in angle 2. Angle 2, if you notice, these are like the scissors, tijeras, and they're opposite of each other. So those are the vertical angles. Okay, so if this is 48 degrees, vertical angles are congruent. They are the same measurement. Okay, so 48 degrees. Angle 4, we can think of these ones as the little boots that we talked in the last lesson, or double L. Since this is 48, these are the double L's, but I mean, it's like the little boots, right? Corresponding there. So Since they have the same position, they have the same measurement. Since number 2 is 48 degrees, then 4 is 48 degrees. Now let's look at number 5. So let me put here 48 degrees, 48 degrees. Number 3, we already said that it's 132 degrees. Now we have another pair of parallel lines. And how do I know that they're parallel? These markings tell me that they are parallel. Okay, this is parallel to this line. This is parallel to this other line. Angle 5, it's right here. We can either do supplementary, which is same side interior angles. Remember that if it forms the C, same side interior angles. Since this is 132 degrees, to make 180, this is going to be 48 degrees. Okay. What else can we find? 6. This can be the half orange right there. Remember that if they're next to each other, they're forming a straight angle, then they are supplementary. Like this one's right here, 180 degrees. Okay, so if this is 48, we're missing 132 degrees, 132 degrees. For this one, I can do one of two. I can do zeta, Z, which is congruent, the same measurement, or I can do letter C for same side. Okay, either one, it's gonna give me 48 degrees. And one is on top, one on the bottom, or one on the side, one on the other side. This is congruent to this one. These will be congruent to them, to each other. So if this is 48, this is going to be 48 degrees. Okay, so those are the angles. Let me write them in here because I was writing it on the diagram. For 6 is 132. For 7 is 48 degrees. And for 8 is also 48 degrees. Okay, so again, in here you can find it in different ways. Whichever one is easier for you, that's fine. For this one, it says find the value of each variable. So the first thing that I recommend for you to do is to identify, okay, this angle is being formed with this angle is being formed with this, and these are the two parallel lines. So what kind of angles are they? Oh, the double L. So it has an double R in there. Okay, so what are the double R? Corresponding angles. Okay, double L, double R, double L, double R. And corresponding angles, you put an equal sign in the middle. So all you have to do is to put 2x plus 10 equals x plus 40. Okay, and the reason is because they are corresponding angles. Corresponding angles. Sometimes it's going to ask you to justify and sometimes it won't. So it's good to know. So the first thing that you're going to do is subtract x from both sides. 2x minus x is x plus 10 equals 40. Then you subtract 10 from both sides and x is equals to 30. So in here you can also justify each step. This is because of the subtraction. I should have put this up above. This is because of the subtraction property, which we learned back in since math 1. This is also subtraction property. And so that's x. Now this tells us to find the value of each variable, and that's all we have to do. This is it. But sometimes it asks you to see, to make sure that they are congruent. And so just check without doing the math if you want to. 30 plus 40, that's going to be 70. 2 times 30 is 60 plus 10 is 70 as well. So for both, you get 70, and that's a way to check super fast that this is the correct value. Here we have a parallelogram, and we know that it's a parallelogram because this tells us that this is parallel to this, and this side is parallel to this other side. When we have two pairs of parallel sides, that means that it's a parallelogram. And what kind of angles do we have here? Let's mark them. This is one of the angles, and this is the other angle. If you notice, they're not facing the same way, so they are not double L. They have to be facing the same way, like in here, for them to be corresponding, but these are not. If you notice in here, they are facing down, but on the left, facing up on the left, facing up on the right. So in here, they're facing each other. So what you do in this case, you just connect it and say, oh, that's letter C, same side interior angles. Same, letter C is for same side interior angles. And you can put just a little angle in there and the symbol. What do we do for same side interior angle? Oh, we add them, and that equals to 180. So remember that in here we add them and we put equals 180. So get one of the expressions for one of the angles, x plus 15, and I'm missing the degrees in there, plus 10x minus 3, and that's going to be equals to 180. Remember, you add them and put equals 180. So now we say, now I'm going a little faster, 6x plus 10x is 16x, 15 minus 3 is positive 12 equals 180. I subtract 12 from both sides. 16x is equals 2. I get 8. 7 minus 1 is 6. And 168. I divide both sides by 16, and at this moment you are able, or you can go ahead and use your calculator. Okay, so with the calculator, you get 168 divided by 16 equals 10.5. Okay, so that again, it just asks for you to find the value of x, but if you had to, you can just replace it. 6 times 10.5, so times 6, and then plus 15, that's equals to 78. The other one is 10 times 10.5, or you just move the decimal, is 105, minus 3, 102. Now if you notice, 78 plus 102, that's 180. They are supplementary. In here, this is a trapezoid. If we remember from one of the modules, the trapezoids, we learned that it has one pair of parallel lines. That means that one of the sides that is not the parallel is a transversal, and this is another transversal. So we're playing with two different ones at the same time. So what you're going to do when you have a trapezoid, you're going to cover one of them. And then think of these as parallel lines, and this is a transversal. So what kind of angles do we have here? This is one of the angles. This is the other angle. And they don't look corresponding. They're not letter Z. So we can connect this, and so no es la Z, it's not Z, it's C, letter C. And for letter C, it's just the one that we did in a minute ago. So we know that when we have this little square, that's 90 degrees. So we put 90 degrees plus 15x equals 180. These are supplementary because of the letter C, okay, right here. Same side is these angles right here. Or we can also have them on this side, okay? It's a backwards C. Okay. Now we subtract 90 from both sides. Oh, and the explanation for this one is that they are same side interior angles. We subtract 90, so that's 15x is equals to 90. Again, well, this is subtraction property, subtraction property. Then we divide by 15 both sides, and so x is equals to, this is the division property. Division property. Okay, and the value 90 divided by 15 is 6. So if we multiply this 6 times 15, that gives us 90 degrees, and 90 and 90, it's 180. Okay, for the other side, now let's do these other two angles. So now we have, remember again, let's look at what kind of angles are they. We have this angle right here. We have this angle right here. They don't look like two little boots or two L's facing the same way. Rather, if we connect it again, it looks like the other letter C. Letter C on this side. Okay, so it's going to be same side interior angle. So the same as this one right here, but on the other side of the trapezoid. So again, we're gonna add them because if they're same side interior angles, this is the addition, that means that we have supplementary angles. Supplementary angles. So plus W minus 30 equals 180. Again, you add the plus, you add the 180. And this is because they are same side interior angles. We combine like terms, we get 2W minus 28 equals 180. This is combine like terms. Sometimes they also say that the justification in here for this one is simplify. Then we add 28 to both sides. This cancels and we get 2W is equals to 208. Finally, we divide by 2. Oh, and this is the addition property. Okay, right there. Addition property. Combine like terms and same side interior angles. Okay, this is because of the division property, which means that we divide both sides by 2, and so W is equals to 104. Again, if we have 104 plus 2, that's going to be 106. If we have 104 minus 30, that's going to be 74. And together, 106 and 74, that's 180 degrees. Okay, one last one. This is specifically two pair of parallel lines with a transversal, and I'm going to introduce also a new kind of angle. If you notice, this is even like if you extend it, they're not going to connect. If you extend it, they're not going to connect. So they're not same side or alternate interior angles. But if you notice, this is a transversal. One angle is on that side, one angle is on this side, so it's alternate. Okay, so it's alternate. But they're not in the interior, whoops, they're not in the interior of the parallel lines. They're in the exterior. So it's called alternate exterior angles. Okay, and these angles is just like the Z. From the A to the Z, they're the same measurement. But also alternate exterior are congruent to each other. Okay, they're congruent angles. They're the same measure. I went through the process and I made a mistake, and I noticed that in here, this is supposed to be a 40. So sorry about that. So this you can kind of see that they are congruent, okay? So that's another hint that helps you guide you. But in here, alternate interior angles and alternate exterior angles are congruent. They're equal to each other. So let's write 2y plus 40 equals 4y minus 2. I subtract 2y from both sides. You get 40 equals 2y. 4y minus 2y is 2y minus 2. Then I add 2 to both sides. And so this is going to be 2y equals 42. Finally, if I'm multiplying by 2, the opposite is to divide by 2. And so y is equals to 21 degrees. So now we can substitute that value just to check to see that they are congruent. And so 2 times 21 plus 40. 2 times 21 is 42 plus 40, that's 82. And you can see that this is not to scale, because in reality it looks like it's more than 100. Okay, and then in here, 4 times 21 minus 2. 4 times 21 is 84 minus 2, that's 82 degrees. So they are congruent to each other. Okay, again, it's not drawn to scale, so in reality it should be more this way. But that's how you say, or how you solve if they are alternate exterior angles, which are not here. They're just similar to these ones where see the green and the green, but if you also jump to here, these are congruent, alternate exterior angles. Well, with this, you have enough material to do 7.6 and have fun. And please don't forget to give it a like, subscribe.